Hello, I'm Saurav Kumar and welcome to the software engineering demonstration. In this video, I'm going to talk about reusable components in software development. We are going to talk about reusability in software engineering and then learn about component reuse. We will discuss their advantages, challenges, and strategies that can be used to mitigate those challenges. We will also look at some design patterns and best practices that developers can employ to create good reusable components. According to Wikipedia, reusability is the use of existing assets such as code, test suites, designs, etc. in some form within the software product development process. Code reuse has been a standard practice from the earliest days of software development. However, as a recognized area of study in software engineering, it dates only from 1968 when Bell Laboratories proposed that the software industry should be based on reusable components. Code reuse aims to decrease the time and effort that goes into producing quality software products. In software engineering, code reuse is implemented by three methods. The first method is called the application system reuse. In application system reuse, the whole of an application system may be reused by incorporating it without change into other systems. This type of reuse is widely practiced as software systems are implemented as application families. The second method is called function reuse. In function reuse, software components implement a single well-defined function that is then reused. This type of reuse is common in application domains where domain-specific libraries of reusable functions have been established. Finally, the last type of reuse is component reuse. In this case, components of a system, from subsystems to a single objects, may be reused. This approach is now seen as the key to widespread reuse of code and technology. Various software engineering approaches are available to software developers today. Here, we will look at some common ones. In the monolithic architecture-based development approach, the entire system is built as a single interconnected unit, where all of the product's code typically resides in a single repository, and any changes to the system require rebuilding and redeploying the entire system. In the object-oriented programming-based development approach, the focus is on creating software systems through the use of objects that can communicate with each other through well-defined interfaces. Domain-driven design-based development focuses on the domain model of the business. Service-oriented architecture-based development emphasizes the use of loosely coupled services which perform specific functions and can be combined together to create more complex systems. Finally, we come to the component-based development. We will look at this approach in the next slide. Component-based development approach relies on the principle of reusability. In this approach, the focus is on creating software components that can be reused across multiple projects and their multiple variants. It emerged from the failure of object-oriented development to support effective reuse, as single object classes are too detailed and too specific. Components instead are more abstract than object classes and can be considered to be standalone service providers. In component-based development, components can be thought of as building blocks that can be assembled to create more complex systems. This approach allows developers to create software systems that are more modular, flexible, and scalable, as they can add, remove, or replace components without affecting the rest of the system. We have spoken a lot about components so far, but haven't defined them. Please pause the video and try to figure out what could be a component in software development. I'll give you 10 seconds to do that. A component is an independent executable entity that can be made up of one or more executable objects. Council and Heinemann define it as a software element that can be deployed independently and composed without modification. Szyperski defines it as a unit of composition that can be deployed independently and is subject to composition by third parties. Components themselves, therefore, independently provide a service without regard to where it is executing or its programming language. They can range in size from simple functions to entire application systems. Reusable components are pre-existing pieces of software that can be used in multiple applications. They encapsulate common functionality or business logic that can be reused across multiple projects or multiple versions of the same product. They help developers build applications more efficiently and with higher quality. Reusable components can take many forms, such as software libraries, frameworks, and APIs. Libraries and application frameworks enable code reuse on a large scale. APIs do it on a comparatively smaller scale by allowing third-party services to integrate with them and use their logic. These components offer many advantages that make the life of a developer easier. They are known to increase efficiency. By using pre-built components, developers can save time and effort and focus on building the unique parts of their application. Reusable components can be used in a variety of applications and contexts, which can make it easier to adapt and modify applications as needed. Since these components are reused in multiple places, they are often rigorously tested and maintained, which in turn reduces the likelihood of bugs or errors in the application. Using these components, a dev team can enforce consistent coding and design standards. Finally, the use of reusable components across multiple projects promotes collaboration and knowledge sharing among developers. Here, we see a small example of code reusability in web application development. A web page has been broken down into smaller components such as buttons, sliders, navbars, and search bars. The codes for these components reside in separate repositories. To create an application, a developer needs to simply import these small components and place them in their code. In the image, we can see that the same set of components are being used to create two different applications. Now that we are aware of the definition, forms, and advantages of reusable components, let's look at some best practices to follow when creating them. Identification of common functionality or business logic that is likely to be used in multiple applications or projects is the most important step. The created components also need to be modular and extensible so that they can be easily integrated into different applications and can be customized in the future if necessary. Components should be designed with a clear separation of concerns so that they can be used in a wide variety of use cases. The use of common design patterns ensure that the component is consistent with established best practices. Using a version control system helps track the changes to the component over time and ensures that multiple versions of it can coexist without conflicts. At the same time, thorough testing protects them from bugs and inconsistencies. Some commonly used design patterns for component-based software development include factory methods, singleton, and observer patterns. The factory method allows developers to create objects without specifying the exact class of the object. Singletons ensure that only one instance of a class exists. Observer patterns are used when a component needs to react to changes in another component. These are just a few examples of the many design patterns that can be used to create reusable components. By incorporating design patterns into their development process, developers can create more flexible, maintainable, and extensible software. Having understood the scope, purpose, and benefits of reusable components, let's see if you can identify the related challenges. Feel free to pause the video for 10 seconds and think about it. While using reusable components can provide many benefits, there are also several challenges that developers may face when working with them. The components should be sufficiently general to cover multiple use cases without sacrificing generality. If multiple projects use different versions of the same component, then managing those versions properly could also become a bottleneck. Developers also need to make sure that different components are compatible with each other, especially if they were developed independently or by different teams. When reusable components become more complex, understanding their functionality so that they can be used effectively can become challenging. Despite these challenges, there are several strategies that developers can use to overcome them, such as implementing several variants of components which can be used on different abstraction levels, or the use of semantic versioning to track component compatibility. By creating well-defined and well-documented APIs for components, developers can increase the component's adaptation and minimize application-level complexity. The use of reusable components in software development has today become mainstream as the programmers have realized its true potential and prowess. However, not every reusable component is a good reusable component. Developers need not sacrifice efficiency to enable reusability. The same could be achieved by following best practices and standard design patterns. In conclusion, the importance of using reusable components in software development cannot be overstated. By leveraging pre-built software components, developers can save time, improve quality, and build more flexible, scalable, and efficient applications. Thank you for watching this presentation. I hope you found this helpful. Until next time.